Hello again, everyone. So great, many of you have handed in your first quiz, and that is very good. You can hand them in at any time, or you can hand them in at the end, whichever is your choosing. So we are moving on to the second unit, and what I'm going to do is I'm always going to have the particular unit we're on at the top of the sheet so that you don't have to scroll down. If you need to scroll down, the unit we just got done doing would be the next one. So you'll also see, again, Mr. May's material from Khan Academy, but it'll always be towards the top, and then again, just click on that particular link that you need. Also this week, you will be having our mentors that Mr. Rakoff has so wonderfully organized, checking up on you to see if you need anything, and they're going to record that in a spreadsheet that I'll look at, because I spend all of my time doing lesson plans. So it takes about 4 to 5 hours to start a new unit, and I think I'm going to be a little over 6 a.m. today, and then 2 or 3 every day to really do good lesson plans. So a lot of my time is spent monitoring emails, doing lesson plans. So we all need some help in checking up on you. And so you'll have mentors calling your house every couple weeks. I think 5th hour is Mrs. Breen. And then 1st, 3rd, and 4th is Tessa Joseph. So they'll be calling you to check up, and they'll just be recording in a spreadsheet that I have access to if there's anything that you need. All right, so we are moving on, and you'll notice that there are 4 sets of notes. You probably need to just be familiar with 3 of them, actually 2 of them. The graphing piecewise functions on a graphing calculator. That's really cool to know. It's not necessary to do this unit, but I also want to prepare you for the future if you're moving on. So these 2 in the middle, composing functions notes, inverse notes, are probably good to refer to or print off as we begin today. So you'll see this. This is what the composing functions notes looks like. This is the inverse function concept that I'll be referring to on and off. Graphing piecewise functions. I think I'm going to make a separate video there, and then just some old material with what a function is in the different representations of a function. So for today, let me get moving along here. We are going to now deal with a unit on functions from the perspective of function evaluation, especially with evaluating composed functions. So what are composed functions? That means that one function or functional value becomes the independent variable in the other function. And if you want material to read on this, I'm not going to read this to you. You can read through it. There are examples of every single possibility that this assignment covers, and you should go through those. Okay, and this basically will take you through all of today's material if you want some further instructions so that I'm not spending too much time on this. So f of g of -4, what does that expression mean when we're given these 2 functions? And the best thing that I can tell you is this innermost numeric value, or maybe it's a variable or variable expression, that is x, or the independent variable in the g function. And then you're just going to figure out, to start with, what is g of -4. Okay, so -4 is going to go in, and I would recommend, if you're going to use a calculator to help you, that you use parentheses around values that you substitute in for. If you do not do this, you are going to get many wrong answers. okay, especially when you're inputting negatives. So 4 is that, and that becomes the value. So I just input that. G of negative 4 is 4. Now we're doing f of 4 in the top function, so that x becomes a 4, and then this is 9. So no matter how many of these you have wrapped inside each other, it's just an inside-out game, and that's what you do. So g of f of 8. Well, we want to know what is f of 8 first. So 8 goes in. Again, parentheses is nice. That's 56. So we're doing g of 56. And so 56 goes into the g function. Then you add 1. That becomes 57. I don't think I guess I did put this in my notes. You need to understand this before I just fly through this. F of 4 equals 9 means the coordinate 4, 9 is on the f function. Okay, you need to understand that this is notation, meaning that, okay, the coordinate 4, 9 is on the f function. That's very important to know that. G of negative 3. So now you have a substitution twice in the same function, which is okay. So negative 3 goes in, you get negative 6. So that becomes the new value inside the parentheses. Then negative 6 goes back into the g function, negative 12. F of negative 1, same way here. So negative 1 will go in, and that becomes 1. Okay, so negative 4 plus 5 is 1. F of 1, that would be 9. H of g of negative 2. So g of 2, not negative 2. So 2 goes in for g, that would be 11. 8 plus 3, 11. Most of these you can do without your calculator. And then h of 11. So that's 11 times negative 3, negative 33 plus 1, negative 32. And then h of g of negative 1. So we want to figure out g of negative 1. That would be negative 4. And then h of negative 4. So here's another one that we want to probably use our calculator to do, and use parentheses around what you're substituting in for. If you don't do that, you're going to get a lot of these wrong that are more difficult. All right, so tables in the big print for the old guys that need the big print here. F of g of 0. So using a table, you just go to the particular function, g of 0. That means when x is 0, find the y. That's 3. Now I'm going to write this down again. F of 3. So that means go to the f function when x is 3, y is negative 2. So it's just a game of going back and forth, hopping from one function to the next. F of 7. So you go to the f function and there is no x equals 7. So this is an undefined answer, just meaning that the table isn't defined out to x equals 7, so there's nothing we can do. G of f of negative 2. So we go to negative 2 in the f function. That's negative 3. So I'm going to write this down. It's probably good to write down that middle step. And then g of negative 3. So that would be equal to 8. And then g of negative 2. So we go to negative 2 on the g function. That's 4. So let's write that down. And then g of 4 is 11. Writing down that middle step, I think, really helps in this. And it makes your assignments quicker and easier. Same thing here when we're using graphs. So h of 0, and we might have to approximate a little bit on some of these. So this is the h function's the line, the f function is the quadratic. So h of 0 is 6. And then f of 6, so we go to 6 on the quadratic, so it's just finding coordinates. So there it is right there, that is equal to 6. remember, f of 6 equals 6. That means the coordinate 6, 6. F of 1. So we go to the quadratic. F of 1 is -5. So now we do f of -5, and that is -2. So you just go to the next, this answer becomes the next x value. F of h of 2. So on the line, h of 2 is 2. And then we want to do f of 2. So these are x values that you look at. Anything inside the parentheses is an independent variable value, and that an x value. And so that's where you always go. So h of 3, so I go to x equals 3 on the h function, that is 0. And then h of 0, so I go to x equals 0 on the h function, that takes me back to 6. It's really pretty simple. Just remember, anything inside the parentheses is an x value in that function. So I don't think of it. X equals 0 in the h function. That's all I'm worried about. And then I go find the y. And then that answer becomes the next x value in the next most outer letter function. So we get 6 for h of 0. That goes in. And now x equals 6 in the f function. And we go look the y value up. So you're looking up y values on charts, on graphs. You might be computing them from the function. You are finding outputs, y values. Last two problems. Now, these are just composing functions without evaluations. So h of g of x, what does that equal? That means well, let's do the intermediate here. That means h of 4x plus 3. That's what that means. We're putting 4x plus 3 in for x in the h function. A little confusing, but that's literally what you do. And if you write down this intermediate step, it might help. All in all, these are much easier than our logarithm section. And just make sure that you crunch out correctly the simplification. These can get more complicated. You'll see in your notes some examples of, especially in the inverses, proving inverses page, they can get more complicated in the algebra. F of a and g of a, find f of g of a. So we're trying to find f of a squared minus 4. What does that equal? Okay, well, that means that a squared minus 4 goes in for a in the f function, whatever that particular variable is. And then you keep everything else the same. So we got to make sure we add 5 on the end like that. Up here, we got to make sure we add the 1 on the end. And then just simplify. And I could make these pretty complicated algebraically. You might have a FOIL product in there, but it is the idea that is important. And so you have your assignment, and we will continue on Thursday. So we're always going to take every Wednesday off, regardless of whether we have a lot going on or a little, just so you have that midweek break to get yourself kind of caught up again. And Thursday we'll move on to inverses.